PLC, Programmable Logic Controller. Three words that sound incredibly complicated, but the concept behind them is actually one of the simplest in all of industrial automation. Before PLCs existed, factories used hundreds, sometimes thousands, of individual relays wired together to control machines. If you wanted to change how the machine worked, you had to rewire it. Physically, by hand, it could take days. Then the PLC was invented, and everything changed. In this video, I'm going to break down exactly what a PLC is, how it thinks, and why learning PLCs is one of the most valuable skills you can have in modern industrial automation. No prior experience needed. Let's get into it. Welcome back to Panel Design Pro. At its most basic level, a PLC is an industrial computer, not a laptop, not a desktop, an industrial computer built to survive in harsh environments, extreme temperatures, vibration, dust, electrical noise, places that would destroy a regular computer in minutes. But like any computer, it has three fundamental jobs. It reads inputs, it executes a program, and it controls outputs. That's it. That's all a PLC does. Read inputs, run program, control outputs. Over and over again, hundreds of times per second. This continuous loop is called the scan cycle. The PLC scans all its inputs, runs through the program logic once, updates all its outputs, and then starts over. A typical scan cycle takes between 1 and 10 milliseconds, meaning the PLC is reevaluating the entire program 100 to 1,000 times every single second. This is what makes PLCs so reliable for controlling industrial machinery. They never stop, they never get tired, they never miss a scan. Let's talk about inputs first. An input is any signal coming into the PLC from the real world. Think of inputs as the PLC's senses, its eyes and ears. Inputs can be discrete, meaning they are either on or off. A push button is a discrete input. Either someone is pressing it or they're not. A limit switch is discrete. Either the door is open or it's closed. A proximity sensor is discrete. Either the part is there or it isn't. Inputs can also be analog, meaning they have a range of values rather than just on and off. A temperature sensor might send a signal anywhere from 4 to 20 milliamps, representing a temperature range of 0 to 200 degrees. A pressure transmitter, a flow meter, a level sensor, these are all analog inputs. Now outputs, an output is any signal going out of the PLC to control something in the real world. Think of outputs as the PLC's hands, what it uses to actually do things. Discrete outputs turn things on or off. A motor contactor coil is a discrete output. Either the motor runs or it doesn't. A solenoid valve, an indicator light, an alarm horn, all discrete outputs. Analog outputs control things over a range. A variable frequency drive that controls motor speed, a control valve that modulates flow, a heating element with variable power. These are controlled by analog outputs sending a 4 to 20 milliamp or 0 to 10 volt signal. Now here's the part that makes everything click. A PLC doesn't just blindly turn outputs on and off, it makes decisions based on logic. And that logic is written by a programmer in a language the PLC understands. The most common language is called ladder logic. We'll cover ladder logic in depth in the next video, but for now think of it like this. The program inside a PLC is a set of if-then rules. If this condition is true, then do this action. If the start button is pressed and the safety door is closed and the e-stop is not pressed, then turn on the motor. If the motor temperature exceeds 180 degrees, then turn off the motor and turn on the fault light and send an alarm signal to the control room. Every single behavior of an automated machine comes down to these if-then rules, and the PLC evaluates all of them every scan cycle, hundreds of times per second. This is why PLCs replaced relay logic. Before PLCs, you needed a physical relay for every single if-then decision. A machine with 50 decisions needed 50 relays. A machine with 500 decisions needed 500 relays. With a PLC, all of that logic lives in software. One device, completely reprogrammable, without touching a single wire. Let's look at what a PLC actually consists of physically. Every PLC system has four main hardware components. First, the CPU, the central processing unit. This is the brain of the PLC. It executes the program, manages memory, and coordinates everything else. The CPU is what you program. Second, the power supply. The PLC needs power to operate, typically 24 volts DC. The power supply module converts incoming power to the regulated voltage the CPU and I/O cards need. Third, input cards, also called input modules. These are the physical connection points where field devices wire into the PLC. Each input card has a set of terminals, one per input point. Your push buttons, sensors, and switches all wire to input card terminals. Fourth, output cards, also called output modules. These are the physical connection points where the PLC connects to the devices it controls. Motor contactor coils, solenoid valves, and indicator lights all wire to output card terminals. PLCs come in two main form factors. Fixed PLCs have a set number of inputs and outputs built into one unit. You can't add more. They're less expensive and great for smaller applications. Modular PLCs have a base rack where you slide in individual cards, CPU, power supply, input cards, output cards. You can expand a modular PLC by adding more cards as your application grows. This is what you'll typically see in larger industrial panels. So, why does any of this matter to you as a panel designer? Because every modern industrial control panel that controls more than the simplest machine has a PLC in it. Motor starters, conveyors, packaging lines, HVAC systems, water treatment plants, oil and gas facilities, they all use PLCs, and the panel designer is responsible for selecting the right PLC, sizing the I/O correctly, wiring all the field devices to the input and output cards, and documenting all of it in the schematic drawings. Understanding how a PLC works makes you a dramatically better panel designer. You understand why certain things are wired the way they are. You understand what the inputs and outputs actually do. And you can communicate intelligently with the controls engineers who write the programs. You don't need to be a PLC programmer to be a great panel designer, but you absolutely need to understand how PLCs work. Let's recap what you learned today. A PLC is an industrial computer that reads inputs, executes a program, and controls outputs continuously in a scan cycle hundreds of times per second. Discrete inputs and outputs are on or off. Analog inputs and outputs operate over a range of values. A PLC makes decisions using if-then logic, the same logic that used to require hundreds of physical relays. Every PLC system has four main hardware components: CPU, power supply, input cards, and output cards. And understanding PLCs makes you a better panel designer. In the next video, we're going to go one level deeper. PLC ladder logic explained for complete beginners. We'll look at real ladder logic diagrams and show you exactly how the if-then logic gets translated into a program the PLC can execute. If this video helped you, hit subscribe and leave a comment below. I'd love to know, are you learning PLCs for a new job, a career change, or just out of curiosity? Let me know. I'll see you in the next one.